So applying that wave shift formula I talked about before, claim here is that we can rewrite this sum difference of sine and cosine as a sine with a shift to it. So we want to figure out what the value of A is and what the value of theta is there. So here's the way we'll go about that. So one way to think about this is if we started off with A sine of x plus, and that's the Greek symbol phi there, we could think about using the angle sum formula for the sine, and the A is just hanging on there. So that would be A sine of x cosine of phi, and then sine gets the signs right. So plus the A is still hanging out and the cosine and sine switch, cosine of x, sine of phi. Now x is my variable here. Phi is just some fixed shift. So that's the phase shift, it's just some number. We got to figure out what number that is. So the A is a constant, so is the cosine of phi. The A is a constant, so is the sine of phi. So A cosine phi is just some constant. Oops, phi or phi. Let's see, phi, phi, pho, phum. Yeah, there we go. Sine of x, and then we have plus A. I'm just going to rewrite this, the constants first. Cosine of x. And again, these guys right here are just some constants. And in the formula, when I first wrote this down, they're not the same constant because this is a cosine and that's a sine. I just relabeled them m and n. So we're going to find an m sine of x and then an n cosine of x here. So we want to figure out what those are. Now, we have some hints here. We have a -3 sine of x, and then a +3 cosine of x there. So putting this all together, my constant m here was a cosine of that phi, and that has to be -3. So a cosine of phi, my two missing numbers, that has to be -3. Now I also know here my constant, a sine of phi, oops. There we go. That has to be +3. Rewriting this one more time, if I move the A to the other side, then the sine of phi has to be 3 over A, and the cosine of phi has to be -3 over A. And to put all this together, we're just going to think about the Pythagorean theorem. Which says sine squared of an angle plus cosine squared of the angle always has to be 1. So now my cosine squared is the -3A, -3 over A. So I'd have to write that like that, squared. And this one would be 3 over A squared, right? Because that's what the sine and cosine are equal to. That sum has to be 1. So now I can solve for A. Now I'm squaring it, so I have to multiply A squared to the other side. And that's going to leave a -3 squared, which is 9, plus a 3 squared, which is 9 on that side. So this tells me that A has to be the square root of 9 plus 9, or 18. And we could clean that up a little bit. Since 18 is 9 times 2, I could say that is 3 times the square root of 2, right? Because that's the same thing as square root of 9 times 2, square root of 9 is 3. So now I got the value of A. Next thing I need to do is find the value of phi here, and I could use either the sine or the cosine to do that. Let's see, let's think about this. Here they say that phi has to be between negative pi and pi. And I think, doesn't matter which one I use. I'm going to go for the cosine. So let's say cosine of phi. I now know a, right? So I'm going to plug it in here, is negative 3 over 3 square root of 2 is what we calculated. That cleans up a little bit. The 3's divide out. So that's negative 1 over the square root of 2. And if you don't recognize that immediately, you could rationalize the denominator, multiply top and bottom by square root of 2. And I get negative square root of 2 over 2. And I think, oh, that's one of the special numbers on the unit circle. So here's my unit circle. And cosine on the unit circle is x. So x, negative square root of 2 over 2 is about over here, which leads to this point up there or that point down there. And if I use the arc cosine to solve this, then I'm going to get phi is the arc cosine of that, which is going to give me this point up here. And the angle that it's going to give me right there would be 1, 2, 3 pi over 4. And that is definitely in the interval from negative pi over 2 to, sorry, negative pi to pi, right? Way over to here would be pi. I'm just right here. So that's my angle phi. So let's graph this to check it out. So I think that negative 3 sine plus 3 cosine is equal to 3 square root of 2. That's what I think A is, times the sine of x plus 3 pi over 4. Whew. As I mentioned, that direction is the harder direction. I don't know of an easier way to come about that. So let's graph it and check. All right, so we started with, let's see, make sure I get the order right, negative 3 sine. Negative 3 sine of x plus 3 cosine of x. And we were asked to rewrite that as a single sine function. And we came up with 3 square root of 2 times the sine parentheses x plus 3 pi over 4. And it looks like the blue wave is sitting right on top. Let's see, move my toolbar out of the way. If we turn off the blue, we see the red sitting underneath. Yep, did that right. Whew. That was a tough one. So what's the secret here? We have to compare. Come on, notebook, come back here. Oh, you're hiding over here. I knew that. We have to compare what the angle sum tells us to what we were given here. So we change this a sine of x plus phi into the angle sum formula, and then we compare the constant parts of that to the constant parts of the given equation. So again, first step was the angle sum formula. Second step was to compare the constant part here to the constant part here. Right, so that gave us an equation with my 2 missing numbers. Constant part here compared to the constant part here gave me another equation with 2 numbers. If I have 2 unknowns and 2 equations, I should be able to solve. Now, since we have cosines and sines in here, this is a nonlinear system, which is always harder to solve than a linear system. And it turns out the trick to then solve that is the Pythagorean theorem. Allowed us to finish that off.